Hi, 7th graders. We are going to talk about Chapter 7, Lesson 1. This lesson is all about adjacent and vertical angles. And it's on page 270, so go and open up your books. All right, so the very first thing you see on page 270 is the classification of angles, and we talked a lot about that in the last lesson. We talked about acute, how they're less than 90, so basically acute angles are anything from 1 degrees to 89 degrees. Right angles are exactly 90, nothing more, nothing less. Obtuse are 91 degrees to 179 degrees, not 180, because 180 is exactly straight line. You're going to need to know a lot of this information for today's lesson. The other thing you're going to need for today is this graphic organizer. I'm not sure which number this is. This might be 2, 3, 4. I don't remember. But you need this one. So you can pause the video, go get that. At the top, we're going to write 7.1. And on 7.1, we're also going to write the title, and that is Adjacent and Vertical Angles. Make sure I spell this right, because that'd be silly. ACENT. Adjacent and vertical CAL, sorry. Angles. And if you had me in 3rd grade, I tried teaching you guys the difference between angle and angel. So I tried to make a silly little thing to remember that. Picture an angel with very curly, beautiful hair, right? So here's the cute little angel, and she has winglings. Okay, she's got bat wings now, apparently. But imagine this little chubby angel here, and she's got curly hair. And so how do angels keep their hair really curly? They need lots of gel for their hair. So that's how you spell angel, is A-N, gel. Angels use gel in their hair. Angles don't. Gull versus gel. So don't get those two mixed up. We don't want a whole bunch of adjacent angles or vertical angels. Okay. Adjacent and vertical angels. I almost said angels now. Angles. So the first thing we see is an activity, drawing angles. Draw the hands on the clock to represent the given type of angle. So on part A, if I said draw me an acute angle, that could be anything. It could be literally anything. So I want you to draw me a ray, first of all. The ray is going to have its dot in the middle, and I don't care which way your ray goes. It could come out this way. Like I said, there's like an infinite number of ways your ray could come out. I'm just going to go ahead and draw my ray going to the 3, just because that's easy. Remember, rays use arrows. Okay, and then I want acute, which, once again, this is acute all the way to about here, not 12 o'clock, 3 o'clock. 3 o'clock would not be acute, that's 90. And then also not anything past, unless I go this way. Now, do you see how that's still an acute angle? Until I get to the 6, now it's a 90-degree angle again. So basically, it's going to be anything from almost a 6 to almost a 12. I'm thinking I'm going to make an acute angle right there just for fun. Okay, a straight angle, which is just 180 degrees. Literally, just go ahead and draw me your ray, and then it can just go straight down to 6. Now, once again, can your ray literally go anywhere? Yeah, your ray can go anywhere as long as it is a straight line, right? Okay, a right angle. I'll just make 3 o'clock. Make it easy, right? Boop, boop. Don't forget your arrows. And obtuse as a moose. Okay, so draw my ray. And obviously it won't be anything over here. This would be about 90 degrees. So anything greater than 90, I could even stop right there. Obtuse. This is kind of a cool angle because you see how it's obtuse both ways? For example, that one's obtuse. And that one's obtuse. That one's huge. This angle right here is greater than 180 degrees because 180 degrees is a straight line. Interesting how that works. If this is a 90-degree angle, could you tell me what the angle is right here? You can, and we're actually going to learn all about that today. The next thing is the meaning of a word, adjacent. When two states are adjacent, like for example, Maine and New Hampshire, it means that they share a common border. Think about the states that are adjacent to Montana. The states that are adjacent to Montana, oh, you guys are gonna love my terrible drawing of Montana. The states that are adjacent to Montana are Idaho, and then down below us we've got Wyoming, and over to the other sides over here we got North Dakota, we got South Dakota, and then up here we have Canada. Adjacent means that you are sharing a side. They are next to one another and they share a common border. So I would say that Maine and New Hampshire are adjacent to one another. That is an important thing to understand because today we will be talking about adjacent angles. We're going to skip the rest of the activities and now we're going to go ahead and get right into the lesson, and we will be now filling out our notes. In the center right here, I don't really know what we should put. Maybe let's just put adjacent versus vertical. Adjacent versus vertical. Adjacent versus vertical. Okay. So over here, key idea, super important. Let's read it. Adjacent angles are two angles that share a common side and have the same vertex. Remember, vertex is that center. The vertex is like when I make a ray, the vertex is that dot right there. So on an angle, the vertex is the point, okay? So let's look at their example. We've got two lines crossing, and there's the vertex in the center. We labeled the angles 1, 2, 3, and 4. It says angle 1 and angle 2 are adjacent because they share this line as a border. Angle 2 and angle 4 are not adjacent because they don't share a border. That little crisscross in the center is not a border. A border would be kind of like a state, right? So I would say 1 and 2 are adjacent. 2 and 3 are adjacent. 3 and 4 are adjacent. 4 and 1 are adjacent. Does that make sense? I hope so. So let's go ahead and hop over to our graphic organizer and let's write down adjacent angles. Okay, and then I'm going to go ahead and take the highlighter and highlight all this. Remember, guys, you can always pause the video if I go too fast or if you want to make your notes look nice. Pause it. Don't worry about time. I make these videos kind of shorter so that you can pause and have time in class. Adjacent angles share a common side. After you draw, or after you write that, I want you to go ahead and draw me two lines crisscrossing. Okay? And I want you to label them 1, 2, 3, and 4. We're going to go ahead and down here in the extra space, we're just going to go ahead and explain the adjacent angles, kind of like what that example did. So we can say angle. Oh yeah, and I wanted to remind you guys, or let you know, this is how we write the word angle shorthand. You have to be so careful though, because what could that angle sign look like in like sloppy kid handwriting? Could it look like an L? Yes. Could it look like a less than sign? Yes. Could it look like, if you're really absolutely insane and crazy, could it look like a Z? Could it look like a 2? Could it look like something? I don't know. It could look like a lot of things. So how I want you to write angle is it's not similar to how the book does it. I want you to do it like this. Angle with a little arc in the center. That way it very clearly looks like an angle with an arc and not an L or a less than sign. So I will say angle 2 and angle, let's say 3, are adjacent. Can you guys give me another one? Let's do angle 3 and angle 4 are adjacent. How about angle 4 and angle 1? And then I've got angle 1 and angle 2. Okay. So adjacent angles are ones that share a common side. I'm even going to draw a little arc right here, draw a little arc right here, and I can see that those guys are adjacent because they share the blue side. Okay? Adjacent angles share a common side. Let's go ahead and read the next example. Vertical angles. A vertical angle, let me grab my highlighter. A vertical angle is when two angles are opposite of one another, and they are formed by the intersection of two lines. So see how this is two lines intersecting with one another? Vertical angles are also called congruent because they are the exact same. So looking at these, 1 and 3 are congruent because they are vertical angles. I always remember vertical angles by making a V with both of my hands. So I want you to do that right now. Put your pencils down. See, I put mine down. Make a V with both hands. And then I want you to stick your wrists together so that your V's are opposite of one another. So like your wrists would be the common vertex in the center. Vertical angles are across from one another, and they're the exact same. So let's go hop over here on our graphic organizer and let's write the word vertical angle. Vertical angles are on opposite sides and are congruent. And once again, I'll grab my highlighter. I'll pick a different color this time. Vertical angles are on opposite sides and are congruent. And I want you guys to go ahead and draw me two intersecting lines again. And we are going to number them 1, 2, 3, and 4. This time I'm going to go ahead and show that 2 and 4, those two angles are vertical angles. They are directly across from one another, and that means they're also congruent. And then 1 and 3 are directly across from one another, which means they are congruent. So down here I'm going to say angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. Okay, so adjacents share a side like states. Vertical are opposites by making two V's with your hands, one on the left, one on the right, and then putting your wrists together. That would make vertical angles. And the other big thing to remember here is that vertical angles are congruent to one another. I'm going to go ahead and highlight that as well, because I do think that that is equally as important as the word vertical angle. All right, so all we've done so far is just read the key idea. Let's go look through some of these examples. Naming angles. Whoa, look at this picture. We've got some crazy lines intersecting. I've got a line here, and then I've got a ray coming out of that line. Pretty crazy. And then I've got points all over the line. It looks like the common vertex they all share is B, and then there's a point on all the lines. Name a pair of adjacent angles. So the example they gave us said angle A, B, and C. So this angle right there share a common side with A, B, and F right there. They also share the same vertex, B, which is perfect, right? So you could say ABC and ABF are vertical angles. What side do they share? Yep, they share that side right there. So those would be vertical. B says, name a pair of vertical angles. I just said the wrong word. These are adjacent, sorry. Adjacent means they share the side. They are sharing the side. Now let's talk about vertical angles. Vertical angles are on opposite sides and they are congruent. We have to be super careful with this one. For example, I could not say, here I'll do this in blue, I would not say EBD and FBA are vertical. Because are they perfectly across from one another, or is this guy just like a little bit tilted off to the side? Which means I could not say that those are vertical, okay? However, I can see that FBA, that angle, and DBC, I feel like those ones are directly across from one another, and those look congruent to me. And that's what it does say. It says ABF and CBD are vertical angles because they are sharing a vertex, which is great, we share B, but they're also on opposite sides of one another. Name two pairs of adjacent angles and two pairs of vertical angles in this figure. Okay, so let's find two pairs of adjacents and two pairs of verticals. So adjacent means they share a side. So I could say angle, gotta practice writing it this way, angle ZWV. That would be this guy right there. Let's name another one that's adjacent. How about angle XWV? Those are adjacent because they share this side right there. Okay, let's name another pair of adjacent angles. I've got angle, let's do ZWY, and let's mix it up. Let's do angle ZWV. ZWV. Those are adjacent because they share that side. This angle and this angle share that side. Now we need to name two vertical angles. I'll do vertical in red. Oops, I'm bouncing around all over here. Okay, vertical are opposites, right? So I could say angle VWX and angle ZWY. Those are vertical because those two are congruent. Okay, and then another one that I could do, the only other one I could do, is angle VWZ, so this guy, and angle XWY. Okay, so those would be vertical because these two are the same. Do you guys notice that I put the vertex that they share? I always put the vertex in the middle when naming an angle. And you can kind of see that that's true on all these answers. Who is the vertex? W. So shouldn't W be the middle thing on everything if they're all sharing that vertex? So just make sure you guys keep that in mind too. Oh, look at this crazy one. Okay. Just for time's sake, I'm not going to write down like the angle, name, whatever. Let's just look at them. Let's do adjacent first. Remember, adjacent shares a side. So I could say angle QJK is adjacent to KJL, and they share that side. I could say QJP is adjacent to PJN, and they share that side. Now let's do vertical. Vertical are right across from one another. It looks like we have a ton of vertical angles this time. I would say this angle and this angle, those two are adjacent, or sorry, vertical. NJP and KJL. I could say this angle and this angle are vertical. That's QJP and MJL. And it looks like I could say this angle and this angle are vertical, so NJM and QJK. All right, let's go to the next page. Next page says, tell whether the angles are adjacent or vertical, and then find the value of x. Ooh, this is where the juicy stuff happens. This is the good stuff, guys. Now, I want you to remember, angles that are directly across from one another are called vertical, and they happen to be congruent. If this is 70, this has to be 70. So when proving what the value of x is with vertical angles, it's super easy. It's literally just that angle, like 70 is x is 70, okay? Now let's talk about adjacent. Adjacent angles won't always equal 90 degrees, but in this case, are these two angles adjacent? I have an angle here, and then I also have an angle here. Do they share a common side, kind of like a state with a border? Yes, they do. So they're definitely adjacent, which means I can use the sum of both of these together and have it equal what the whole thing is. I know the whole thing is 90 degrees because they told me it was 90 degrees with that little square corner. See that? That tells me it's 90 degrees. So if that's the case, then can't I say this angle, which is x plus 4, plus this angle, which is 31, can't I say all of it together should equal 90? Now to solve for x, combine my like terms. This would be x plus 34 equals 90. How do I get x all by itself? Well, let me get a sheet of paper and give us more room to work. To get x by itself, I have to do the opposite of what's happening. It is being added by 34, so the opposite of that would be to subtract 34 to both sides. These 34s cancel out. Goodbye. We go ahead and borrow 8, 10, 6, 8, 7, 6, 5. Boom. X equals 56. And then I can pop it in here and say, okay, if this is 56, what's 56 plus 4? 60. So this angle is 60 degrees, and this angle is, 31. Oh, I must have made a small little error. Oh, doy. You guys, it's like bedtime, so while you're watching this and you're like, Mrs. Ringler, no, 31 plus 4 is not 34. Don't panic, I noticed it too. And can I just like take this as a learning moment for a moment? How did I know I made a mistake? Why did I stop and go, wait a second, why isn't this working? Well, what I did is I looked at these two angles and I said, wait a second, 60 plus 31 is 91. 91 degrees is not a perfect square corner. So that's why I was like, oh, wait a second. Something must have happened. And in my delusioned brain, I realized what happened. 4 plus 31 is 35. Man, I'm a dingbat. All right, now subtract the 35. Much, much better. Okay, now plug in 55 for x. 55 plus 4, that's 59. Now that makes so much more sense because 59 plus 31, now we've got 90 degrees. Oh my goodness. Okay, well that was a great learning opportunity for us now, wasn't it? All right, let me go and erase this page. Let's go ahead and do some of these in our notes. Let's go here and let's say solving vertical angles. Solving vertical angles, and then I want you guys to draw me two lines intersecting. And if I told you this was 105 degrees, and I say, now what's x? I want you to go ahead and take a highlighter and show me that these angles are identical. So I'm going to highlight 105 and I'm going to highlight x. Vertical angles, the ones directly across from one another, are identical. They're congruent. X equals 105. Let's do another solving over here. But this time let's say solving adjacent angles. And here's what we're going to draw for this one. Let's draw that. So draw me a 90-degree. And you can go ahead and show me that it's 90 degrees by making a perfect little square in the middle. And let's go ahead and split it. So we're going to make a nice little acute angle down here. Okay, don't forget your arrows, because remember, these are lines that go on forever. And inside, let's say that this is 69 degrees, and this one is 2x minus 1. Okay, so how do you solve adjacent angles? Well, what we do is we see, okay, both of those angles together, added up, should equal 90 degrees. So I could say 69 plus 2x minus 1 equals 90 degrees. And then you just go ahead and solve it. Combine your like terms first. 69 minus 1 is 68. And then let's go ahead and get rid of our extra stuff around the x before dealing directly with what's happening to x. So before I can get rid of my 2, I have to get rid of that 68. It's a positive 68, so I'll do the opposite by subtracting it. That leaves me with 2x equals 2, 6, 7, 8. That's a 2, 22. That's nice. Okay, divide by 2. Divide by 2, because it's being multiplied, right? 2 over 2 is 1 whole, which means that goes away. X equals 11. 22 divided by 2 is 11. So then I can go ahead and pop that 11 in there. And I would say 2 times 11 minus 1. 2 times 11 is 22. 22 minus 1 equals 21. And then to make sure you did it right, do, like I did last time, make sure you do it right by saying 69 plus 21. That should be 90 degrees. 9 and 1 is 10. 6, 7, 8, 9. Yep, 90 degrees. Oofta, did it right this time. Okay, so today's lesson, we learned 2 really important words, adjacent and vertical. Adjacent means they share a side like a state. Vertical means that they are opposite of one another, but it means that they are then congruent, okay? Solving vertical angles is very easy. Solving adjacent angles, you have to do a little bit of math with it, but you just know that it's this angle plus this angle will equal the whole angle, okay? And I believe that was all the examples. So now we're on to the exercises. Let's see here. So you do have a bell ringer for today, and it will be left sitting out for you to do. So after your bell ringer, I would like you guys to do an exit ticket as well. Let's go ahead and let's do, what does this say? Tell whether the angles are adjacent or vertical. Then find the value of x. Okay, so they would be worth 2 points each, right? First you have to tell me if they're adjacent or vertical. Then find the value of x. All right, let's do 8 and 11. 8 and 11 are your exit ticket questions. So I'll go ahead and copy and paste that. And I will put it over here so that you guys can see this nicely. I'll just stick it in your guys' bell ringers. Boop. Okay. Oh, that's 8th grade. Okay. And I will paste this right here. All right, so here is your exit ticket. exit ticket 7.1 and your name. So remember, I want you to tell me if they're adjacent or vertical first. Then I want you to solve for x and find the angle measure, okay? All right, guys. That is it for today. Remember, if you need any help on doing your exit ticket or your bell ringer, always go back to this video, rewatch it, maybe look over the notes, make sure you didn't miss anything, maybe even go back in the chapter and just reread some of it for yourself and see if it makes sense. Your bell ringer today is down here. Solve the inequality, graph the solution. So let me remind you, when solving for inequalities, you want to get the variable by itself. If you are multiplying or dividing by negative, what happens to your sign? It flips. And if you look at 27, how would I get n by itself? I would divide it by -6. If I'm dividing by negative, alarm should be going off in your head. Flip, flip, flip. So this would make n less than -9. Then graph it. Go to -9. Put an open circle, not closed. N is smaller, which means anything that way. Well, there you go. I just gave you a free answer on 27. Let's look at 30. What is the slope of the line that passes through the points 2, 3 and 6, 8? I'll give you a quick little reminder. Slope equals the change in y's over the change in x's. And remember, this is x comma y, x comma y. So here's what I want you to do. I want you to take 3 minus 8. That would be the change, right? Change means difference. Difference means subtract. After you do that, that's your top number. And then I want you to take 2 minus 6. That would be your bottom number. All right, guys, good luck.